This video is sponsored by PCBWay. Hello there and welcome back to another video. In today's video, I'm going to be doing my take on a budget NAS that you can reasonably build even in today's really rough economy. Many people have made videos on budget NAS builds at this point on this platform, all with slightly different perspectives on what might be a good idea versus a bad idea, whether or not drives should be included in the price, and a ton of other things. Now, I've got a few ideas of my own on these topics, and so I'll be sharing a budget NAS that I've managed to build with these ideas that has 2 drives of redundancy, 12 terabytes of usable storage, and it has both of those things for under $250, which I think is decently impressive, knowing just how expensive tech has become in the past few years. So, what are these ideas that I have surrounding things like whether drives should be included, what capacity drives should be used, how you should build it, and a bunch of other stuff? Well, if you couldn't tell, based on the fact that I quote an exact amount of usable storage, this NAS will have drives included in its total cost. Additionally, the exact kind of drives that we'll be using is something that I actually don't see very often on this platform at all, especially for these budget NAS builds. And with how well this ended up working for me, I honestly have very little clue as to why this isn't a bigger thing. But before I get into the details of that, let's first talk about the base system that this NAS will be built on, as all NASs need some kind of computer in order to run. In this case, I found this old desktop computer on eBay, which seems to have been some kind of old custom build. Now, it's important that you get an old desktop PC like this, and by this, I mean something with an actual standard case, instead of an old office PC in some proprietary thing. The reason for this is because these old cases tend to have a ton of drive bays in them, both 3.5 inch and 5.25 inch ones, both of which we'll be utilizing today. I got this computer on eBay for a pretty steep price of $100 because, well, it was on eBay, so it had to be shipped, and this thing's not small. And then also, I bought it completely untested and without specs as a gamble, hoping it had a decent CPU in it that would justify the price, and also hoping that it would be broken, because then I could get a video out of fixing it, and those tend to do quite well on my channel. However, it works fine, and I ended up with basically the shortest end of the stick that I possibly could in terms of CPU for this thing, because it's got an i3-6100 paired with 4 gigs of RAM. So yeah, not a great deal for me, but what that means for you is that it should be easy to get a computer that's at least this powerful while still easily hitting that $250 total price point, even if you don't get quite as good a price on some of the other items as I did. Basically, the fact that I overpaid for this computer builds some buffer into the price that I'm quoting. Moving on from the PC now, let's check out the other parts needed to make this project, the first of which being this PCI Express card called an HBA. An HBA, or host bus adapter, is a controller that communicates with storage devices in computers. These aren't very commonly seen in consumer gear, and most HBAs are therefore ex-enterprise equipment, which means they're both cheap and capable and are, in my opinion, a far better option than those cheap PCI Express to SATA cards that you can find on Amazon. Plus, they're usually only like $10 more, which is really awesome. The particular card that I have today is an LSI 9207-8i card, and there's a couple specific details to mention that are really important when buying these used HBAs. The first one being that this card is flashed into what's called IT mode, and this basically allows it to easily pass drives through to a standard OS. You can flash these cards yourself if you have one that isn't in IT mode, but since a very large majority of these cards that are available on eBay are already flashed into IT mode, and you'd only save like $3 if you went for one that wasn't, I think just buying one that's in IT mode is probably the better option. Then the second thing to keep in mind when purchasing one of these cards is that being ex-enterprise, they're designed to fit into servers where there's a lot of airflow rammed through the whole chassis. Therefore, if you can afford to pick up a small fan to zip tie to the card, that's a really good idea and is likely to even extend the life of your card by not letting it run quite as hot. And I know someone out there is thinking, yeah, but these HBA cards probably don't get that hot, they don't seem to do that much, and therefore that small heatsink working passively is probably fine. And to that I say, boy would you be surprised just how hot these things get. I've had 10 gig network cards that are honestly fine without a fan on them, but these things run so hot that I recommend a fan always. With the HBA aside, I also made sure that I had some suitable cables for it. Now, it might be easy to find an HBA card that comes with 2 mini SAS SFF 8087 connectors that break out into 4 standard SATA connectors at the end, but don't buy one of those, because for this project, that is not what we need. Instead, we need these cables, called SFF 8087-8482 cables. I know it's a really catchy name, but basically, these guys take the 2 SAS connections on the HBA and break them out into 4 actual SAS connectors that can connect to SAS and SATA drives. And they have a nice little spot to attach a SATA power connector so that you can power your drives off of a standard power supply. And this is really important because of the drives that I chose for this project, which are these 8 2TB SAS hard drives. I ended up buying these SAS drives because they were way cheaper than any SATA ones that I could find on the market, and these are the exact reason that I'm so particular about these cables, because if you bought the ones that broke out into SATA connectors, you can't plug these drives in. You have to make sure that the cables for your HBA terminate in SAS connectors if you want to be able to use SAS drives, therefore making this project possible under that $250 ceiling. But in any case, let's talk a little more about these hard drives, which ended up costing me only $100 in total, and that will provide us with 16 terabytes of raw storage. However, since they're used drives and not even recertified ones, I think that I'll run this setup with 2 drives worth of redundancy for 12 terabytes of usable space, while allowing for up to 2 drive failures before any real data loss occurs, which I deem quite important when you have this large a number of very heavily used drives. And also, as a quick side note, I do want to say that used 4 terabyte SAS drives are also really cheap, and you can actually get 4 4TB drives for about $100 as well. The only difference there is that to get 12 terabytes of usable space, you can only run with up to 1 drive failure, which might be a little risky feeling for heavily used, super cheap drives. Plus, you'll end up with lower speeds due to having fewer drives working together, though this all comes at the advantage of easily being able to expand your storage way more because there will be more free drive bays. And I know that I've talked a lot so far while basically building nothing, so let's go ahead and start the build process by repasting the CPU. But while I do this, there's one more thing for me to touch on that I know at least a few people are wondering, and that is, well, you're buying all of this old enterprise SAS gear, and that's awesome, but what happens if in the future I want to buy SATA drives? Well, I have a great answer for that. See, here's the thing. SAS drives will not work with a SATA controller. In fact, their connectors are designed so that SATA power and data cables cannot plug into a SAS drive. However, the thing is that SATA drives will actually work just fine with a SAS controller. Plus, these special cables, which are necessary for SAS drives, still fit standard SATA drives, and this is by design. So if one day you switch out all or even just a few of the drives here with SATA drives, you should be able to just plug the SATA drives into the cables and they should recognize and work exactly like a SAS drive would. Plus, if in the future you manage to find a bunch of good SAS drives for cheap, because that does happen, you're already set to run them. And this is the part of the video that I'm talking about not seeing many YouTubers cover. Using old SAS hardware for its low cost, while also being really good at leaving the doors open for basically any upgrade that you could want to do down the line. But with that said, let's go ahead and get our HBA and all of our drives installed into this computer. Now, this PC came with a 500GB hard drive, which would be perfectly suitable to use for a boot drive for the NAS's OS. However, for the sake of speeding things up, I'll be installing a small 256GB SSD. I didn't factor this into the budget, but only because it's not really necessary, and the only thing it really changes for me is how fast the NAS boots up while I'm filming, which also, in an actual use case, shouldn't matter much because you're likely not turning your NAS on and off all the time. Also, I do want to note, if you are thinking of going for an SSD for your OS, You really don't need 256 gigs. A 128 or even 64 gig drive should be just fine if you can find one. So after mounting 5 of the hard drives to all of the 3.5-inch bays in this case, we've got to figure out where the other 3 are gonna go. And the great thing for us is that these old cases generally have a lot of 5.25-inch drive bays, which were used for all kinds of optical drives. And the thing is that with these bays, you can easily 3D print adapters to change these bays into 3.5-inch bays. Of course, not everyone has a 3D printer available to them though, and that's where the sponsor of today's video comes in, PCBWay. PCBWay is a company that offers many different high-quality custom manufacturing services, including PCB production, CNC machining, and of course 3D printing as some of their main ones. So if you need a 3D printed part for a project, for example for a NAS like this, check out what PCBWay can do to print you all the parts you need. Plus, in the very near future, I have a really cool project I'm working on where I'm making one of these adapters that has a built-in fan in the front and that has a little PCB in the back that is able to power all of the hard drives in it with just a single PCI Express cable instead of a mess of SATA power connectors and splitters. But in any case, hopefully you can see just how useful PCBWay services can be when working on projects of all kinds, especially with computers. And if you think that PCBWay's manufacturing services could aid in your next project, check them out at the link in the video description, and thank you again to PCBWay for sponsoring this video. Moving on, I 3D printed this adapter, which is quite overkill for this exact build because it's designed for 4 drives and is really chunky. But I went with this adapter because it's my own design for that future project I mentioned just a moment ago, and I needed to prototype it to test its mounting hole locations, all of which ended up being slightly off. So I'm glad that I prototyped it. Anyway, I'll leave a link to a more suitable model in the description below if you're following along. Moving forward though, with the other 3 drives now mounted in the adapter in the 5.25-inch bays, I can move on to the final step before plugging everything in, and that is installing a simple case fan I had laying around to the front of this case. And this is because this case has a really nice addition of a place to mount a fan right in front of all of the drive bays, and since I had an extra one laying around, I chose to do this, as these drives do get relatively warm, and keeping them cool in use is never a bad thing. And so finally, I can get to plugging stuff in, and I started by plugging the 2 SAS cables into the HBA, and then plugging all of their ends into the hard drives. This is really quite simple, and exactly which drive gets plugged in where doesn't matter at all. The only note here is that these blue SAS cables, while looking awesome and being conveniently thin for cable management, are even more fragile than they look. Try your best not to kink them or twist them, especially not repeatedly, while you're assembling the system, as they can and will break if treated wrong. Then I grabbed several SATA power splitters, which are super cheap to find on Amazon, and I used them to connect all the hard drives to the power supply in this system, as it only has 4 SATA power connectors on it. And now, because our SSD is already installed into the system, we can go ahead and close it up and boot it. Now, after seeing that the system posted fine, I went ahead and created a TrueNas Scale USB, and I went with Scale because it's Linux based, and I know Linux far better than the free BSD that TrueNas Core and Enterprise are based on. This meant that I figured it was a much better choice for ease of troubleshooting and compatibility. However, when I tried to boot this USB I created, it would continually error out. I found out after a few tries that you'll likely have to change your motherboard's boot mode to Legacy instead of UEFI to get the installer to load successfully, and after doing this, everything worked properly. With the installer booted, we're presented with a menu to select our boot media, where I'll go ahead and I'll select the Intel SSD I installed, but hold on a moment, is that a 1TB drive? Yeah, it sure is. It seems that the eBay seller I bought these drives from ended up making a genuine, easy to make mistake and ended up sending me 7 2TB drives and then one 1TB drive of the exact same model. Upon contacting the seller, they sent me a replacement 2TB drive, which I promptly installed, but I wanted to address this for anyone who sees the 1TB drive show up in the next bit of B-roll, as I left it installed in the system until I started setting up the actual storage pool, which I did with the new 2TB drive once it arrived. In any case, I moved through the installer, and once it was all done, I opened up the web interface in my browser. Now, I do want to be clear, this isn't a TrueNas tutorial video, which is why I'm glossing over a lot of this stuff and will continue to do so. This is mainly a video about a cool hardware configuration, and I'm just using TrueNas to demonstrate it because I feel like that's what a lot of people will use. Therefore, I'll be sure to include some links to some really good TrueNas tutorials in the description. Once I was in the web UI, I was able to create a storage pool with the 8 2TB drives that showed up without a single hitch. Nice. To run these drives in a setup that allows for 2 of them to fail before data is lost, I selected RAID Z2 as the layout. If you want 3 drives of redundancy, go RAID Z3, or if you're playing it a little less safe, go with RAID Z1, or really it's just called RAID Z, for the most usable storage, but the least fault tolerance. Now, with a storage pool created, I set up a dataset, user, and SMB share, which will allow me to log into the NAS and actually start putting files onto it. After that was done, I was able to log into the share from my computer over the network, and when copying some files over to the new NAS, I had no issues consistently saturating its 1 gigabit per second interface. So heck yeah, that's a NAS. We've made something that stores our files on a bunch of hard drives in an array that's accessible over the network. We're done here, right? Well, apart from finalizing the TrueNas install to your taste, yeah, you're done here. But there is one thing that I want to investigate just for the fun of it before I go ahead and put this NAS away and end the video. And I do want to be clear, the hardware in this part of the video is not factored into the $250 price tag, and it's not something I'd actually recommend running, at least in the way that I'm doing it. But I still chose to test this for the sake of completeness and for providing some information that might be useful down the road if you're copying this build. This is a 10 gigabit per second fiber optic network card. In particular, it's an old Hewlett-Packard Enterprise 530 SFP Plus that I think I got with transceivers for about $12 on eBay. I want to install this into the system to see just how much performance this array of 8 drives can offer, as that is one of the main advantages to using more drives: higher performance. However, the motherboard in this computer honestly sucks, so I have to use this M.2 to PCI Express adapter to install this card, as the rest of the PCIe slots on the motherboard that aren't taken up by the HBA are all PCIe X1. And this is the part of the setup that I don't recommend actually running, but if your board has the right PCIe port, that being some X4 or greater port, I totally recommend upgrading the networking if you have the budget to do so. In any case, after installing it and plugging the fiber cable into the fiber network I have in my filming room, I configured the IP in TrueNas and had 10 gigabit connectivity to the NAS. After grabbing some footage to move on and off of it, well, holy crap, this thing is fast. When writing to the NAS, it seems to sustain a speed of around 400 megabytes per second, which seems to be about twice the speed of a single drive, aligning with my expectations pretty much perfectly. Then, when reading from the NAS, it actually works out that my SSDs, even my nice main Windows drive and my Thunderbolt external SSD, can't keep up for the whole time. This is because it seems that this NAS could sustain a speed of around 750 to 800 megabytes per second as long as the SSD wasn't getting overloaded. So yeah, if you were wondering, this NAS is really performant, and a networking upgrade down the road would be money well spent. Well, that's all that I have to show you in today's video. I think that this budget NAS turned out amazingly. It offers a ton of storage space, especially for the price, reasonable redundancy, enough performance to justify a 10 gig network upgrade in the future, and of course, the ability to be upgraded with basically whatever drives you could ever want due to the fact that it's already rocking a SAS controller, hence enabling you to use both SAS and SATA drives. It may not be the most energy efficient or compact NAS to ever exist, and it definitely uses a lot of drives to get this amount of storage, but it's a NAS that you can build today for less than $250 that offers 12 whole terabytes of usable storage and true drives of redundancy. So I don't think there's too much to complain about. I hope that you were able to at least enjoy this video and maybe even learn a thing or two. In any case, I hope to see you next time. Goodbye.